Hello, welcome. This is going to be lesson one in the momentum unit. And in this unit, we're going to talk about what is momentum and also what is its partner, which is impulse. All right. My name is Mr. Tompkins, and we'll go ahead and get started. Here we go. The objectives. This is what you are going to do in today's lecture, or what you should know. You should compare the momentum of different moving objects. You should be able to compare the momentum of the same object moving with different velocities, identify examples of change in momentum, and describe changes in the momentum in terms of forces and times. Now, why do you need to know about momentum? Well, this is very simple. The designers of personal protective equipment, i.e. Helmets, knee pads, elbow pads, they utilize the idea of this impulse and momentum to help protect you. Also, automobiles are designed to slow down the change in momentum of an object by crumpling. So automobile makers do take into account the idea of momentum, and you can only play pool or billiards if momentum ever existed. Now, what is momentum? Momentum is another way to describe the motion of an object. We use the term momentum to describe the object's mass, or some object with a mass moving with some velocity. Momentum is represented by the symbol P because it was originally called impetus, which comes from the Latin word peter, or to move towards or rush upon. So the symbol is P. Please don't get that confused with power, which we've seen already, but it is a lowercase p and not a capital P. Now, momentum is given by the equation where the momentum equals the mass times the velocity. It has a very original unit of kilograms times meters per second, or kilogram meters per second, and it is a vector. And the vector of the momentum, or the direction of the momentum, points in the direction of the object's velocity. Now, why do we need another way to describe motion? Well, momentum is used to understand how the duration of a force affects the motion of an object. It's good for describing collisions. There's some limitations to what we've learned so far when it comes to collisions. Kinematic equations cannot predict what happens after a collision. Neither can energy, because energy is so easily lost due to internal energy or being converted into other forms of energy through external means, through sound, through crumpling, and those kinds of things. So we can't really use energy to make predictions on objects whenever they go through collisions. Now, mass matters in momentum because the equation mass times velocity. The more mass of an object has, the more momentum it has. Also, the faster the object is moving, so the velocity does have a part in it, the more momentum we'll have. And we could have the same momentum with a very large object moving very slow and a very small object moving very fast. Now, impulse. This is like momentum's cousin, and we'll learn the relationship between impulse and momentum soon. But it's basically the effect of a force on an object over a period of time. So it's what does a force, or how does a force change an object over a period of time? And it's given by the equation where the impulse equals the force times the time period, so how long that force is on the object. And now you are going to conduct a lab where you're going to find the relationship between momentum and impulse.